All right, in this video, I'm going to be going over SAT problems. These are from an old test prep book. You can tell it's old because there are five choices in the multiple choice. In the SAT nowadays, there's only A, B, C, and D. This one has choice E even, so that's how you can tell it's old. They got rid of choice E. I don't know what year, but it's not quite a while ago, actually. But regardless, there's some good problems to practice here. And of course, just to practice your test taking strategies as well. All right, without further ado, let's begin. This is question number one. This chapter is about triangles. So these problems will be all about triangles, and I'll go over the concepts that are needed for each problem. I list them out this time. So hopefully this can be helpful for identifying what you might need to review. Okay, let's begin. Problem number one. This says, what is the value of x? So I would recommend you try it first on your own if you don't have the problem set. So pause the video and try it on your own and then come back to see the solution and how I solve it. All right. So a lot of the times there's multiple ways to solve these. I try to write what I think um, or how I thought through the problem. And it might not be the quickest way, and that's the point that I'm trying to show you that I'll identify the quicker way if there is one, but this is how I thought through the problems that you can mimic if you find it helpful. And if you don't find it helpful and you found a better way to do it for yourself, do that way instead. Okay. Anyway, so here we can understand the concept of an exterior angle. All right. This 130 degree is an exterior angle. It's not inside the triangle, but it's supplementary to one of the angles in the triangle. So this 130 degrees is an exterior angle. And there's a theorem that says this exterior angle is the sum of these two angles over here, the non-adjacent interior angles. Okay, so we can solve an equation. 130 equals x plus 70. So x is equal to 60, choice A. Number two, what is the measure of angle ABC? Okay, what's the concept this one is trying to test? This one most likely is trying to assess that you know what the sum of the interior angles of a triangle is. The sum of these three angles should equal to 180. Okay? So this is a thought process. To find this angle ABC, we probably need to find what x is, and then that's when we use the concept of the sum of the interior angles is 180 to help find out what this x is. So 5x plus 4x plus 3x equals 180. That's this line right here. And then we solve for x is equal to 15. Don't forget to answer the question though, because it's a common trap. You might see 15 as one of the choices. In this case, it's not here, but you get excited, you bubble it in, or it gets in a digital SAT, you go click it, or whatever it is, and then you move on. But you didn't answer the question. We have to answer the question. It's asking for a measure of angle ABC. ABC is 5x, so 5 times 15 is 75. Choice E. Number three, what is y minus x in this diagram? Okay, we can again use the sum of the interior angles is 180. And specifically for these triangles, these are both right triangles. There's a right angle as one of the angles. Therefore, the other two angles must sum up to 90 degrees. They're complementary. Okay, so you can use either concept. It's just the complementary angles just results because only because one of the angles is a right angle. Okay, so 90 equals x plus 40, so x must be 50, and 90 equals 20 plus y must be 70 then. So what are we answering? Y minus x, so be careful. Y minus x is 70 minus 50, which is 20, choice E. So you can see 50 would be a trap answer. There's no 70, but 50 is x. That's the trap right there. Don't pick that. Answer the question. Okay. Question number four. Which of the following statements is correct? Go ahead and pause the video and try this on your own. Okay. This is testing two different concepts. First of all, we might need to know what this angle is over here. So again, the concept of the sum of the interior angles is 180 degrees. So this angle, angle C, is 180 minus 59 minus 61, okay, which is 60. So measure of angle C is 60. And then the second concept this is trying to test is the larger the angle, the longer the opposite side to the angle. Okay? So angle A is the smallest, so the side opposite to it, so BC would be the shortest side of the triangle. And then 60 was next, so AB is the second shortest. And then this is the biggest, angle B, so the side opposite to it, AC, is the largest. So choice B. Okay. Question 5. What is the area of the triangle below? Okay. Testing two concepts. First of all, 45, 45, 90 special right angle triangles, right triangles. And then what is the area of a triangle? It's half the base times the height. This is the base. This is the height. Okay. In this case, for this 45, 45, 90 triangle, the base and the height are the same length. Okay. And so base and height are equal to 4 over root 2 by the special triangle. Okay. By the way, this angle is also 45 because, again, these two angles need to be complementary, or these three angles must sum up to 180, okay? So therefore, the area is half times 4 over square root of 2 squared, okay? So if you square this guy, square the top, that's 16, square the bottom, that's 2, okay? So then it becomes 16 over 4, which is 4. Answer is A. Question 6, measure of angle ABC is equal to x. What is the value of x? All right, so BAC is x. They don't give us any angles in this triangle. So what do we do? Is it a special triangle that we should know? What are the two special triangles? 45, 45, 90, and 30, 60, 90. Those are the most common ones that this exam tests. All right. Is it a 45, 45, 90 triangle? It clearly isn't because, like in the other problem, two of the legs must be equal in length, the non-hypotenuse legs, basically. And in this case, all three are different. So we rule that out. Okay? By the way, is it even a right triangle? We can even confirm by doing the Pythagorean theorem. It should be, okay? Or we can realize that it is a 30, 60, 90 triangle because, well, the hypotenuse is twice of one of the lanes. So look, 4 root 3 times 2 is 8 root 3. And then if this is the shortest side, okay, which is opposite to the 30-degree angle, how do we get to the other side over here? You multiply by root 3. So 4 root 3 times another root 3, so that's the same thing as 4 times 3, which is 12. This is a 30, 60, 90 triangle. Okay, so as I was saying, this is the shortest side over here, so that's the 30 degrees, and that's BAC. So that's whatever over here. Okay. Number 7, the area of the triangle below is 56 centimeters squared. What is the height of the triangle? Okay, this one should be simple. Area of a triangle is half the base times the height. This is a right triangle, so that makes it very easy. This is the base, this is the height. Okay, so we have area, we have base, we need to find height. We just use the formula to solve for h. So I used the wrong letter, but the answer should be 16. There we go. Okay. Give it a second to save. Okay. Question 8. Which of the following could be the lanes of the sides of a triangle? Do we remember this concept? Concept that this is testing is when you take two sides of a triangle and you sum it, that sum should be larger than the third side. Okay? That's this concept I wrote up here. So what's the strategy that we can do? Instead of summing every pair of two within these three lanes in each of the three cases, so that you're going to be doing a lot, just pick the shortest two sides and see if it exceeds the third side. The sum exceeds the third side. Because if we don't pick the smallest two, the sum will for sure exceed the side we didn't pick. Okay, you can try that on your own to convince yourself, but if not, you just believe me for now. So let's go choice by choice. 3 plus 3, those are the two shortest sides, is equal to 6. The rule is it has to exceed. It cannot even be equal. So is it greater than 6? No. So we cross that out. Okay. 3 plus 4 is 7. Is that bigger than 8 in choice 2? No. So cross that out. How about 4 plus 5? That's 9, which is bigger than 8. So we're good there. Only 3 works. Choice C. Number 9. If the angles of a triangle have a ratio of 1 to 2 to 3, which of the following statements are true? Okay. So we have to first remember that ratio is relative. So when it's like 1 to 2, that means the second item is twice as much as the first item. Okay. So if we kind of want to notate it as a variable, we can translate this sentence as, well, if this first angle is x, then the next angle is 2x, and the third angle is 3x, okay? So that's what I'm saying, this bullet point over here. And then concept number 2, we have the sum of the interior angles is 180. So we have x plus 2x, this should be a 2 over here, plus 3x is equal to 180. So 6x is 180, x is 30 as a result, all right? Okay, so let's look at the choices. The triangle is a right triangle, is that right? It is because x is 30. So one of the angles is, or the second angle is 60. The third angle is 90. So 90 means right triangle. Okay. So we're good there. How about item number 2? The ratio of the sides are 1 to square root of 3 to 2. Yes, this is a 30-60-90 triangle relationship. Okay. And then, as I just said, it's 30-60-90 triangle. So 3 is true as well. So all 3 are true. Number 10, what is y minus x? All right, there's probably multiple ways we can do this, but this is how I thought of it, okay? So we know that the sum of the interior angles is 180 degrees. It's a common theme. So x must be 180 minus 80 minus 50, which means it's 50, okay? That's concept number 1 up here. And then this 50-degree angle is a vertical angle to this K that I marked here in blue. Hopefully you can see it. Okay. Vertical angles are congruent, meaning K is 50 as well. And then we can use concept 1 again. Sum of the angles is 180. So y is 180 minus 70 minus 50, which is 60. Okay. We got to answer the question. Don't fall for any traps. Y minus x is 60 minus 50. That is 10. Choice E. We're lucky that there's no 50 and there's no 60 as choices. So if you weren't paying attention, you would have lucked out. Right? Number 11, what is the measure of angle CBA? Right? We can again use the exterior angle theorem, which says that this exterior angle is the sum of these two non-adjacent angles. Okay? So 5x is equal to 3x plus 50. We solve for x. X is 25. Choice E. Number 12. What is the perimeter of an equilateral triangle with a height of 6 feet? Okay, if you remember the conversion from the height of the equilateral triangle to the side of the equilateral triangle, great. I never remember it, so let's derive it. Okay, so don't get confused that the height of the triangle is not the length of the side, okay? That's why I put in red up here. So don't get confused about that. In this case, We're lucky that there's no choice of 18. Okay. But anyway, so what is perimeter, first of all? We have to know what that is. Perimeter is the sum of the lengths of all the sides. Okay, so we need the length of a side of a triangle. Okay. Now, we also know that concept number two, an equilateral triangle has interior angles that are all 60 degrees. Equilateral triangles have sides that are equal and also angles that are equal. Okay. And then concept number three, this is more so because it works for isosceles triangles, which an equilateral triangle is an isosceles triangle. There's another side that's equal, but you can classify it as an isosceles per se as well. Okay. If you draw the heights in an isosceles triangle, it bisects the side, meaning it splits it in half. It also bisects the angle. Okay. That's an important theorem that we need to know. Okay. So from concept two, each angle is 60. So this one remains 60, but this height will bisect the 60-degree angle, which means it halves it. So it's 30 over here. Okay, so this is the 30, 60, 90 triangle. We know this is 6. So this opposite to 60. So this is concept this is still concept theory, I guess, and it split it up. So since this is 6, to get to this side, opposite to 30, you divide by square root of 3. And then to get to the hypotenuse, you take the side opposite to the 30-degree angle, and you multiply it by 2. So the side is 12 root 3. And the perimeter is side plus side plus side. So 3 times the side length. All right. Which is 12 root 3. Okay, so I guess I did some simplification. So 12 over root 3, if we rationalize it, it's 4 root 3. And then for the perimeter, we multiply 4 root 3 by 3, which is 12 root 3. Okay, typically, if I guess I forced myself to do it here, maybe afterward, but typically I just leave it and rationalize at the end. A lot of times it's easier, but depends on the problem. All right, number 13. What is x plus y? Here, all we need is the Pythagorean theorem, which relates the sides in a right triangle. A squared plus b squared equals c squared. That sounds familiar, right? So this is a right triangle. So side squared plus the other side squared equals the hypotenuse squared. So that's the a squared plus b squared equals c squared. So let's write the formula. 18 squared plus y squared is 30 squared. We can find that y equals 24. And then this is another right triangle, so we can use the Pythagorean theorem again. So the hypotenuse squared, x squared, is 10 squared plus what did we just find y as? 24. So 24 squared. And we use the calculator to find x is equal to 26. Let's answer the question. This is a free response, so don't just bubble in 26 or 24. Okay. I guess type it in the digital SAT now. We got to answer the question. 24 plus 26, that is 50. Be careful to answer the question. Number 14, two sides of a triangle are 7 and 16. Which of the following is not the length of the third side? We went over this concept a few problems back, or many problems back. I don't remember what number, but do you remember this already? Or did you forget it already? The concept is when we sum two sides, it must exceed the third side in order for it to be a triangle. Okay? So we have to consider two different cases, okay? We can assume that these are the shortest sides, meaning, as the concept says, the sum of these two must exceed the third side. Let's call the third side x, okay? So 7 plus 16 has to be greater than x, which x is less than 23 here, okay? We have to consider another case as well. By the way, these are all less than 23, so that doesn't help us. So that's why we have to also consider a different case. Maybe, perhaps, 16 is the biggest side. So we can set up a different inequality. 7 plus x is greater than 16. Okay, so x is greater than 9. So exactly 9 doesn't work. And this is asking which of the following is not the length of the third side. So choice E is the answer. Okay, one more time. Let me explain one more time. The concept is the sum of two sides of the triangle, or in order for a triangle to work, The sum of two sides, any two sides, must be greater than the remaining side, okay? So we can consider that these two are the shortest sides, and the missing thing is the longest side. So the sum of these two smaller ones, which is 23, must be bigger than the third side. That's this inequality over here, okay? We can also consider that perhaps 16 is the biggest. 7 is less than 16, right? So 7 cannot be the biggest side. That's hopefully obvious. So we can consider 16 to be the biggest. So 7 plus the missing side, x, must be greater than 16. Okay. All right, number 15. Which of the following is the longest side? Okay, so this we also went over. The larger the angle, the longer the opposite side to the angle. Okay, so we also note that BD is shared, okay, between these two triangles. So we might need to use a relative comparison, okay? So in this triangle, ABD, which side is the longest? It's opposite to the biggest angle. This is the biggest angle, angle A. So BD would be the longest, okay? Now, over here in this triangle, which side is the longest? It's CD, because it's opposite to the biggest angle, okay? Now, with some reasoning, we understand that, well, BD is the largest of this triangle, but CD is the largest of this triangle. So CD is bigger than BD, and BD is bigger than anything else over here. CD is the biggest then. Okay, or DC, same thing. That's all the stuff I wrote over there. Okay, number 16. What is A plus B plus C plus X plus Y? I think we're about a little more than halfway through now. There's 26 problems, yeah. Okay. Well, how do we solve this? Again, sum of the interior angles of a triangle. A plus B plus C, these make up a triangle. That's 180. X plus Y, well, X plus Y plus 150 is equal to 180. Did I say 150? X plus Y plus 50 is 180. Okay, so X plus Y is 180 minus 50, which is 130. So 180 plus 130 would be the answer, which is 310. Okay. 17, the area of an equilateral triangle is 36 square root of 3 centimeter squared. What is the height of the triangle? If you remember the formula for the area of an equilateral triangle with just the side as the input, as the variable, great. I think it's like side squared times square root of 3 over 4, something like that. I really don't remember. See, if you don't remember, we have to know how to derive it. That's a trade-off. Okay, so we did this before in a different problem. We know that equilateral triangle has equal length sides and equal measure angles, interior angles. So it will be 60 degrees, okay? And then we can draw the height of the triangle, and that will bisect the angle up here, and will bisect the side down here, the edge down here, okay? So we have this 30, 60, 90 triangle now, okay? If we call the base over here, half the base over here, half the base of the equilateral triangle, I should say, as A, okay? H is A root 3 by 30, 60, 90 triangles, the relationship between the sides, okay? Which we can say A is H over square root of 3, okay? Now we use the area of a triangle is half the base times the height. So 36 root 3 is half the base. What is the base? It's 2a. Be careful there. Okay. And height, so then this simplifies to have to review what I wrote, is AH. And then we can reduce it to one variable by this relationship up there. Solve for H. You get H is 6 square root of 3. Okay. 18. In the figure below, if BC equals 5, then what is AB equal to? Okay, so I don't remember how I solved it, but immediately I'm thinking, well, this is a right triangle, ABC. Okay, and this is the exterior angle, so we can get that this guy over here should be 45. Okay, we could also just do that. These two are supplementary, so this is 180 minus 135, which is 45. And then 90 plus 45 plus this angle is 180, so this is 45 as well. Okay, multiple ways to approach it, as I said before. Okay, but after that, we get that this triangle is a 45, 45, 90 triangle. Okay, so if BC is equal to 5, the AB is the hypotenuse, so 5 root 2. Choice D. Okay, 19. Measure of angle BCA is 45. BAC is 60 degrees. CBA, 75 degrees. BDC equals 9 degrees. If DC is equal to 5, then AD is equal to what? Okay. So whenever you're given a lot of information, it's usually helpful to label all of it, okay? Did I do it though? Looks like I didn't. But, okay, so let's look. BDC is 90 degrees. Okay, so it's a right triangle. Yeah. Both of them are right triangles actually, because this is a straight edge. Yeah. Doesn't say it's not, so we hopefully assume that. Okay, so they're both right, and then BCA is 45 degrees. So this triangle over here is a 45, 45, 90 triangle. Okay, and then BAC is 60 degrees. Whoops, don't know why that's popping up. Where was that? BAC is 60 degrees. So this triangle over here is a 30, 60, 90 triangle. Okay, CBA, I don't know why they gave us that. And actually, I did say over here, it's unnecessary and distracting, so let's ignore that, okay? We have two important pieces of information. This is a 45, 45, 90 triangle. This one over here is 30, 60, 90 triangle. I wish I labeled it beforehand to make it more clear, but hopefully you're doing it as you're trying these problems. Hopefully not just watching me solve them. That's not helpful for you, I would argue. Okay. All right, so DC is equal to 5. What's DC? DC is equal to 5. Okay. So BD is also equal to 5 then, because remember this is a 45, 45, 90 triangle, okay? And if this is equal to 5, this angle was 60 degrees, yeah? So AD is 5 divided by root 3. If we rationalize it, it's 5 root 3 over 3. Choice C. All right. Number 20, what is the value of x? Again, there's probably lots of ways we can approach this. So let me redo it. Maybe I solved it a different way, but let me do it live. Okay. This is an exterior angle to the triangle. So this one over here would be 80 degrees, because 80 plus 60 is 140. Okay. This is a vertical angle with this. These are vertical angles. So this is also 80 degrees. And x, well, we can use the sum of the interior angles. X is 180 minus 80 minus 50. So it's 50 for speed. Okay. So that's exactly how I did it here. Good. Consistent. All right, 21. What is the length of the base of the right triangle below if the area is 20 inches squared? Okay. What's the formula for area? Half the base times the height. Base is x plus 3. Height is x plus 6. We need to solve this quadratic. Luckily, it's factorable. So you can go through the math that I wrote down. So our solutions are x is negative 11 or x is 2. Length must be positive, right? So we choose x is 2. And then we have to be careful again to answer the question. Okay, since x is 2, we're asked for the length of the base. Base is here, 2 plus 3, 5. Okay, by the way, if we had picked x as negative 11, again, the lengths would have been negative, which doesn't make sense, first of all. And then on the SAT, if I remember correctly, you can't even select a negative answer for the free response. That's on the paper because then we couldn't bubble in a negative number. So that's how you can tell it was wrong as well. Okay. 22. What's the value of x? All right. So we want this length over here. We're given this length and this length. So, and we're given that this is a right angle. So maybe we can use the Pythagorean theorem to help us out. Okay. So this length over here, AB, would be, well, if we use the Pythagorean theorem, it would be 6 squared minus square root of 11 squared. And that's all under the square root. So that's what I wrote here. We do the math, it's equal to 5. And then we can use segment addition because AC is equal to AB plus BC. So we can get that BC is just 15, the whole thing, minus this piece over here, which we found is 5. So BC is 10. Look how it's not drawn to scale, by the way. This is 5, but this is 10. So they should, if I remember correctly, they're supposed to put, this is in the College Board, by the way, this is a third-party test prep company, or textbook company, actually. They're supposed to put not drawn to scale, figure not drawn to scale, something like that. So anyway, you got to be careful to not assume things like it's drawn to scale, unless, yeah, in general, I would say that, okay? To not assume things are drawn to scale. Anyway, so BC is equal to 5. Sorry, BC is equal to 10. And then we can use the Pythagorean theorem again, because 10 squared plus square root of 11 squared should be equal to x squared. Okay, and if we do the math, x is square root of 111. All right. 23. If A is greater than B, which of the following statements is true? Comparing the segments looks like. Okay. So again, we're going to probably have to use the concept that the larger the angle, the larger the side as well, the longer the side as well, okay? There's a reason that they gave A is greater than B, because you look at the 60 degrees, you're tempted to think, at least for me, I'll say for myself, oh, well, 60, 60, 60, equilateral triangle. But it cannot be. If A is equal to B, then it could be, this probably is an equilateral triangle. But it specifically says A is greater than B, so it will not be an equilateral triangle, okay? Therefore, since A is greater than B, A must be greater than 60, and B must be less than 60, okay? And therefore, since A is greater than 60, ST will be the biggest, the longest. The 60 degree will be the second biggest angle, so RT will be the second longest. And then B is less than 60, so RS will be the shortest, okay? So that's what I wrote there. So then we gotta just match it up. RT bigger than RS? Yes. ST bigger than RS? Yes. RT bigger than ST? No. So 1 and 2 only. Okay, 24. What is the value of A? We can use some of the interior angles once again. X plus 110 plus Y must be 180. Okay? We don't need to know what X and Y are individually, I'm pretty sure, because, okay, let's just believe me for now. So X plus Y must be 70 then. Okay, that's from this inner triangle. Now the bigger triangle, well, look, X plus Y, this is the whole angle here, plus another X plus Y, plus A must be 180. We found what X plus Y was just now. It was 70, yeah? So 70 plus 70 plus A is 180. So A is 180 minus 140, which is 40. Answer is D. All right. That was hopefully easy. 25 with A plus B plus C plus D. Okay, so I listed all the concepts again. So the sum of the interior angles in a triangle is 180 degrees. Okay. And then sometimes people say this is a straight angle. Okay. Basically a line. These make up a straight angle, which is 180 degrees. Or some books call it, they're all linear. So they make up 180 degrees. Okay. The same with over here. C plus Y plus D, they all sum up to 180 as well. Okay. So if I just Yeah, so I labeled these as X and Y just to help me out. So I know that A plus B plus X is 180, which we can rewrite as A plus B is 180 minus X. Okay. And then C plus D plus Y is 180. So C plus D equals 180 minus Y. And I know that X plus Y plus 50 is 180. So X plus Y is 130. So what are we interested in? We're interested in A plus B plus C plus D. So we add these two over here because A plus B plus C plus D. So add the left-hand sides over here on these two and add the right-hand sides over here for these two. So A plus B plus C plus D would be 180 minus X plus 180 minus Y, which is 360 minus X minus Y, which we can factor out -1, the negative X plus Y, and X plus Y is 130. So the answer is 230. A plus B plus C plus D is 230. Okay, look, trap answer, X plus Y is 130, right there. That's not what the question is asking. Okay, so I would imagine this is one of the harder problems toward the end of the sections. 26, last one. Triangle ABC is an equilateral triangle. Triangle ADC is an isosceles triangle. If AD is equal to 12, what is the area of the shaded region? I have 3 slides to slowly show you all the concepts that you need to solve this problem. Okay, and this is what makes geometry hard for some people. You just have to combine so many different ideas to solve one problem. Kind of like this one already. Well, this one was just 2 ideas and then some algebra that you had to be able to work out to solve it. But this one, there's just lots of concepts. Okay, but list a lot of them. I probably didn't even list all of them out, but anyway. Okay, so we can first have a strategy on how to solve this. To find the area of the shaded region, we probably want to do area of this big triangle minus area of this smaller triangle. Okay, and the big triangle is the equilateral, the smaller triangle is the isosceles. So that's why we're on concept 1. Area shaded is area of equilateral minus area of isosceles. So let's focus on the area of the isosceles first, all right? Okay, so since this is 30 degrees, this is an isosceles triangle, which means that 2 of the sides are congruent, which means they're the same length. And the angles that are opposite to those congruent sides are congruent as well. So since this is 30 degrees, this one over here is going to be 30 as well. Okay? And AD is 12, so DC is also equal to 12. Okay? So we can easily find this angle because, once again, sum of the interior angles of a triangle is 180. So 180 minus 30 minus 30. So this angle, angle D, is 120. Okay, there's 3 concepts already. Now let's continue. Again, we can do the trick where if we draw the height of an isosceles triangle, it bisects the angle and the side. So since it was 120 before, it bisects it. So this angle, the half the angle would be 60, yeah? Okay, and then it tells us that AD is 12. This is the next concept, 30, 60, 90 triangles. Since this is 12, the side opposite to the 30-degree angle would be half the hypotenuse. 12 is the hypotenuse, so over here is 6. And the side opposite to the 60-degree angle would be 6 root 3. Okay? Now we can find the area of this isosceles triangle because since this over here is 6 root 3, remember this height bisected AC, so this half over here is also 6 root 3. So the entire base is 12 root 3, But since the formula is half base times height, this is half the base right here. So 6 root 3 times 6, that's 36 root 3. Okay? We tackled half this problem now. Now we got to find the area of the equilateral triangle. So how do we do that? Well, first of all, next concept. See, I'm really stating out all the concepts. I believe it should be concept 7, actually, over here. Okay? But equilateral triangles have congruent sides and interior angles. So since the sum of the interior angles must be 180 and all three angles are the same, it must be 60 degrees each. Okay, so this is what I marked in this blue over here. This whole angle over here is 60 degrees. And from the isosceles triangle, we found that this over here is 6 root 3. Okay, we can also draw the height for the equilateral triangle. Same thing. It works for equilateral triangles as well. There's just a special case of an isosceles triangle in that the third side is the same as well. So it will bisect this AC once again, and they share the same AC anyway, right? So this is 6 root 3. So the height of this guy would be 6 root 3 times root 3, because this is a 30, 60, 90 triangle again. So again, this is 60 degrees up here because it's equilateral triangle, and then this height bisects it. So over here, it's just 30. Okay. So 6 root 3 times root 3 is 18. Now the area of the equilateral triangle is half the base. So that's 6 root 3 times the height, which is 18. That's 108 root 3. And now putting it all together, put it into concept 1, where we subtract the area. So 108 root 3 minus 36 root 3, 72 root 3 is our answer. Choice B. And that's it for this problem set. Hopefully, me listing out the concepts was helpful if you needed help identifying what you need to review. Hopefully, this is good practice as well. The next chapter will be, if I remember correctly, it was on polygons. So hopefully I see you in that video as well. Bye.